Welcome back to the Explainer. Today, we are tackling a beast, the Google Cloud Storage ecosystem. Look, if you've ever stared at that endless list of database options and felt like you were drowning in an alphabet soup of services, well, you're not alone. We're going to cut through that noise today and give you a rock-solid framework so you can pick the exact right tool for the job every single time.
All right, so here is our roadmap for today. We'll start with foundational cloud storage systems, then choosing your data model. Move into Google Cloud Database options, master those cloud storage classes, and finally, bring it all together by architecting the complete solution. Let's dive in.
Starting right off with Section 1, Foundational Cloud Storage Systems. Okay, so let's talk about speed. You can really just think of Memory Store as your application's short-term memory. It's this fully managed cache service sitting right in front of your database, and it serves up frequently hit queries lightning fast. Because it's caching query results in memory, specifically using Redis setups that can scale all the way up to 300 gigabytes, you're drastically cutting down on disk reads. And that means a massive boost in your app's performance.
Now, speaking of disks, when you're attaching persistent disks to your virtual machines, you've got a really critical choice to make: solid-state drives versus hard disk drives. SSDs, they give you that incredibly low latency you absolutely need for performance-sensitive stuff, like your core databases. But HDDs, that's your piggy bank option. If you're just parking historical data for exploratory analysis and peak performance isn't a big deal, HDDs are perfectly fine and they'll keep those costs way down.
Moving right along to Section 2, choosing your data model. So look, your data model totally dictates how your app actually interacts with its info. If your application demands strict rules, structured tabular formats, and absolute rock-solid strong consistency, say for a banking app that's processing financial transactions, you absolutely need a relational model. It's tailor-made for transaction processing systems where accuracy and transaction support are basically non-negotiable.
On the flip side, what if you don't need those strict table rules? Well, NoSQL gives you a ton of flexibility. In Google Cloud, NoSQL models basically split into two camps based on how you want to query things. You've got document models, which are awesome for complex nested data structures, and wide column models, which are your go-to for massive scale and flatter data setups. All right, let's look at the specific services in Section 3, Google Cloud Database Options.
So both Cloud SQL and Cloud Spanner handle relational data, but they operate at totally different scales. Cloud SQL is your fully managed workhorse for standard, regional apps using MySQL or PostgreSQL. Cloud Spanner, on the other hand, is your high-end, global powerhouse for massive scale. But quick warning, from one architect to another, watch your budget. Deploying Spanner in multi-super regional setups like NAM Eurasia 1 is going to carry the highest hourly costs. Just something to keep in mind.
Over on the NoSQL side, the divide is pretty clear. You want to use Firestore, which is our document database, for mobile backends. The built-in data synchronization between the database and the user's device is a total game changer, plus you don't even have to configure any virtual machines. But you'd bring in Bigtable, our wide column database, when you need to ingest massive, consistent streams of data with low millisecond latency. Just remember that Bigtable actually does require you to configure the underlying VMs.
Now, what if you're building a massive data warehouse? If you need to run standard SQL analytics on literally tens of petabytes of data, and you don't want to mess with underlying VMs, BigQuery is your absolute best friend. It uses an analytical model built for reporting rather than transaction processing. Oh, and one super important detail, before you can store a single byte of data in BigQuery, you have to create a dataset first. Don't forget that step. Let's pivot over to Files in Section 4, Mastering Cloud Storage Classes.
Notice the inverse relationship here between how often you access data and the storage cost across our four classes: Standard, Nearline, Coldline, and Archive. Standard is obviously for frequently accessed stuff. But here's the catch. Choosing Nearline or Coldline to save a few bucks only works if you actually leave those files alone. Retrieving data from those colder tiers hits you with access charges. So if you move daily accessed files to Nearline, you might actually see your bill go up. Yikes!
To automate these cost savings, you're going to use lifecycle rules. You just supply these configs to your buckets to automatically push files down this tier chain over time. But hey, it is a one-way street. You can downgrade a standard class object, sure, but once a file hits Archive, you cannot transition it back up to standard using a lifecycle rule. Archive is literally the end of the line.
Just a quick terminology check before we hit our final section. Cloud storage lets you enable versioning on your buckets so you can keep multiple versions of your files. If you do this, the absolute latest, most recent iteration of that object, well, that is always officially called the live version. Good to know.
All right, bringing it all together in Section 5, Architecting the Complete Solution.
When you are tasked with picking a database for a new feature, you really have to juggle all of these criteria at the exact same time. If you just hyper-focus on cost or only look at read and write patterns, you're going to end up with a broken architecture. You've got to balance consistency, transaction support, and latency all together to make the right call. Let's put this into practice with a real scenario. Imagine you're at a startup building analytics for Internet of Things data. You've got this massive fire hose of time series device data. We're talking petabyte volumes here, and it needs immediate, consistent ingestion with incredibly short write latencies. So what is the exact right tool for the job?
If you said Bigtable, you hit the nail on the head. Firestore, that's a document model, totally wrong fit. Cloud Spanner, great global relational database, but it's not built for high-speed time series ingestion. Bigtable is really the only correct answer here. It's wide column, designed for massive scale, and eats short write latencies for breakfast.
Okay, here's another super common one. A developer on your team has an app where their structured relational database, specifically a MySQL database in Cloud SQL, is lagging. They're willing to tweak the app a bit, but rewriting the whole thing to use a NoSQL model like Firestore? Completely off the table. How do you fix that performance?
The most elegant fix here is a hybrid approach. You slap memory store right in front of Cloud SQL to cache those frequent queries, meaning subsequent reads happen from memory, not disk. Combine that with making sure the database's persistent disks are low-latency SSDs instead of HDDs, and boom, you completely transform the performance profile and you didn't even have to abandon the relational model.
Let's do one more. Modern mobile apps demand seamless offline to online transitions, right? Constant synchronization. So if a mobile dev team asks you for a back-end database that gives them those mobile-specific sync features right out of the box, where are you pointing them?
Firestore is absolutely the perfect tool for this. BigQuery is for analytics, and Spanner and Bigtable don't have built-in mobile sync. Firestore gives mobile devs exactly what they need in a super flexible document structure. And as a huge bonus, they won't have to manage a single virtual machine configuration.
Which brings us to the absolute biggest takeaway of this entire explainer. The true power of Google Cloud isn't about hunting for one magical database that does everything. It's about combining these highly specialized systems. You might have a single app using Memory Store for lightning-fast caches, Cloud SQL for rock-solid transactions, and cloud storage for keeping files long-term, all seamlessly working together. So, armed with this blueprint, what complex, multi-layered solution are you going to architect next?